Thank you, Patrick, for that introduction, and thank you for inviting me to participate in this event. It's always nice to be able to work with you again. Perhaps I should say a few words about my university, because I suspect you will not have heard of it before. It's what we think is the only university in the world that specializes in logistics. It's based in Hamburg in Germany. It's celebrating its 10th anniversary. We're very small still. We've only got about 400 students, but we're very active in research and in teaching. So although I work in Hamburg, I actually live in Edinburgh. And because of the COVID crisis, I've not actually been back to the university now since February last year. So the theme of my talk this morning is going to be the decarbonisation of freight transport. I always feel that in the world of environmental sustainability, freight doesn't get as much attention as does passenger transport. So what I'm going to try and do is correct that imbalance. I'd like to begin by putting freight into context. Sorry, I'm just having a bit of trouble moving on. There we go. Just to get a sense of the contribution of freight transport worldwide to CO2 emissions. So if we start by looking at all the energy-related CO2 emissions in the world, transport accounts for about 23% of that. We then look at the split between passenger and freight. Freight represents, they reckon worldwide, about 42% of those emissions. And then if we look at the division between transport modes, what we discover is that road transport, trucking, accounts for about 2/3 of those freight-related CO2 emissions. Overall, that's about 9% of CO2 emissions from energy generation worldwide. This is a sector which is considered to be very hard to decarbonize for two reasons. Partly because of its very heavy dependence on fossil fuel, but also because of the very fast projected growth rate for freight transport. The International Transport Forum, based in Paris, last year estimated that between 2015 and actually that should be 2050, not 2020, in 2050, there will be a growth in excess of 3.3 times growth in the volume of freight movement, which is going to make it very hard to decarbonize this movement. Now, of course, what we've had in the past year is the pandemic, which has had quite a dramatic effect on freight-related CO2 emissions. The International Transport Forum estimated that during the period of maximum lockdown in April and May last year, that CO2 emissions from freight transport fell by around 28% worldwide by all transport modes. Now, to put that into context, just a few months previously, the International Transport Forum had said that a very worthy target for reducing freight CO2 by 2030 would be a 30% reduction. In other words, the COVID crisis within 2 months drove down freight emissions by the amount that was expected to happen over a period of 10 years to 2030. What that does, I think, is illustrate the magnitude of the required changes that will have to be made to get emissions drastically reduced from freight transport. Now, I'm not suggesting that we should lock down the economy again to achieve that, but it does give people a sense of how radical the changes will have to be. Now, here in Europe, as I'm sure you're aware, there is the Green Deal. And in December, just last month, the EU published its smart and sustainable mobility strategy when it outlined how it hopes to achieve deep reductions in transport emissions. And it's hoping to achieve a 90% reduction in emissions from both passenger and freight transport between 2015 and 2050. And I'll come back and say more about that in just a few moments. Now, so how do we decarbonize freight transport? I published a book on this subject in 2018, and the book is built around a framework that I've developed to advise companies and governments on how they should be decarbonizing their freight transport. I call it the 10C approach because it's in 10 stages, each with an English word beginning with the letter C. So I start with corporate motivation because it's tough. And unless there's a sufficient level of enthusiasm within the business, it's going to be hard to do this. Assuming that exists, the next thing is to calculate your emissions, to see where they're coming from, to get a sense of the carbon intensity of the operation. Next thing is to commit to targets to reduce those emissions. You then have to consider all the possible options available for decarbonizing your freight transport. The feeling is that for us to achieve really deep reductions in freight emissions, companies will have to work together. They'll have to share their logistics assets. So the fifth stage in the process is to look for opportunities to collaborate with other businesses. Then, of course, you have to do a cost evaluation, because obviously every company is going to want to find the most cost-effective ways of decarbonizing their logistics. Armed with all that information, you can then choose the appropriate set of decarbonization actions. You develop your strategy. Now, at that stage, you may discover it's necessary to engage in what we call carbon offsetting, where it may be necessary to pay some other organization to cut emissions on your behalf, because your internal plan is not sufficient to achieve the targets. Having done all that, you then implement your plan, you cut your emissions, and you learn from that experience, because the 10th stage is where you calibrate the strategy. Because in the light of that experience, you may want to go back and modify the targets, for example. Perhaps those targets were too ambitious or not ambitious enough. You may decide that the package of measures that you introduced was inappropriate. But what we've done is we've put feedback loops into the process. This is what we call an iterative process. I think currently many companies are still at a fairly early stage in this process, and for them, essentially, it's a learning experience. Now, I'm just going to select a few of those stages and comment on them a little bit in a bit more detail. First of all, corporate motivation. As an academic, I've spent decades looking at the environmental sustainability of logistics. One thing that I discovered a long time ago is that there's essentially a decision-making hierarchy within logistics, and particularly at 4 levels. I mean, at the highest level are the strategic decisions, often involving a lot of capital investment, relating to the capacity, locations of factories, warehouses, terminals. At the next level down are the commercial decisions relating to the configuration of the supply chain. Where does a company obtain its supplies? How does it distribute to its customers? The next level down are the operational decisions, mainly to do with scheduling of production and distribution. Does a company work on a just-in-time basis, or does it acquire its supplies in bulk over a longer time period? And then at the lowest level are what I call functional decisions, the ones that are made day to day by transport and logistics managers, relating to the routing of a vehicle, for example, or the loading of that vehicle. Now, the amount of freight movement on the ground and the amount of environmental impact that has is the result of the interaction between those 4 levels of decision making. And it seemed to me that a lot of the green initiatives that companies are implementing are at the bottom end of that hierarchy. Relating to vehicle routing or improving the performance of the driver and so forth. But a lot of the good work done at that level is undone or offset by decisions made at a higher level, where companies, for example, decide to centralize their inventory or to source products from more distant locations. And so the point I always made is for a company to be truly green and to properly decarbonize its logistics operations, it really has to involve decision making at all 4 of those levels. And one other thing which I think is very important here is, so much logistics is now outsourced. Companies no longer do it themselves. And therefore that makes the procurement of logistics services, the purchasing of logistics services, very critical. And I'll draw your attention to an interesting report published just last year by the Smart Freight Centre, which offered guidelines to companies on how they could procure their freight transport services in a way that would minimize emissions. Moving on to calculating emissions, This is an interesting subject. I mean, I first got involved in this in 2007, 2008, when there were many different methodologies, many different reporting standards, and many companies simply didn't know which one to use. Different logistics companies were calculating emissions in different ways, and so there was a lack of consistency. Then, thankfully, in 2014, an organization called the Global Logistics Emissions Council was set up with the objective of harmonizing and standardizing the measurement and reporting of emissions. And I think they have done that very effectively. That's their most recent report, giving a company's advice on how they should be doing this. But we're still at a fairly early stage in this process, because much depends on where you draw the boundary around the emission calculation. At the moment, almost all the data we have for freight emissions lie within what we call system boundaries 1 and system boundaries 2, either coming directly from the vehicle or from that figure on a well-to-wheel basis, looking at the energy supply chain. What we currently lack is information on emissions from the maintenance of the vehicles and the infrastructure. We lack data on the embedded emissions in the vehicles, their manufacture, data on the construction and modification of infrastructure. And then right out at system boundary 5, we have very little data on the IT and administrative related emissions from logistics. So at the moment, we only get a partial view, really, of the carbon footprint of logistics. And the hope is that eventually we'll push out that boundary and we'll get a more holistic measure. And then committing to targets, because again, there's been an anomaly until recently, in the sense that many companies have been setting what we call carbon intensity targets for freight transport. You know, where it's CO2 emissions related to a level of activity, ton kilometers or vehicle kilometers or pallet kilometers. But that's not good enough. You know, government targets are absolute targets. It's reductions in the total amount of emissions, not just carbon intensity. So there's currently a move in the logistics sector to get companies to move from carbon intensity targets towards absolute reduction targets. And to help them do that, there's an initiative called the Science-Based Targeting Initiative. They've produced a document encouraging and advising companies on how they should be setting absolute carbon reduction targets. Now, I said a moment ago that much logistics today is outsourced to companies like DHL or Kühne. And thankfully, many of these big companies are setting net zero targets for their CO2 emissions, in most cases by 2050 or earlier. So a company using these logistics providers, in a sense, piggyback on their carbon reduction targets. And then another of my C's is consider possible options, because the good news here is that there are many things that we can do to decarbonize freight transport. And they fall into these 5 categories. First is to reduce the carbon content of the energy that's used in freight transport. Then we can improve the energy efficiency, just reducing the total amount of energy required. We can optimize the loading of the vehicles. We can shift as much freight as possible onto lower carbon modes, away from road to rail or from air to sea. And also, more fundamentally, we can just try to reduce the total amount of freight movement. Now, I'll come back and talk about all of these things in a little bit more detail. But again, having worked as a researcher in this area and having advised a lot of companies and some governments on this, one thing that appears to me is that a lot of the emphasis is placed on vehicle technology and the use of alternative fuels. That is how many decision makers think we're going to decarbonize freight transport. And no question, both of these things will make a big contribution. But we shouldn't overlook the fact that there are many other things that we can do to decarbonize freight. And that's for that reason I've constructed what I call my rectangular onion diagram, because in addition to those things, again, we've got to look at how the vehicles are maintained, how they're driven, how we load them, how we route them in schedule them. I mentioned earlier, we have to ensure we've got the right allocation of freight between different transport modes. And then at even higher level, we may have to redesign our logistic systems or reconfigure our supply chains. Because if we confine our attention to the inner layers in that diagram, what that will do is reduce emissions per vehicle kilometre. But all the forecasts are that we're going to see a huge increase in freight vehicle kilometres. So in the end, we would have higher emissions. It's only if we deploy measures at the outer layers of that diagram that we will reduce the total demand for freight transport, we'll reduce vehicle kilometres, and that will then give us the possibility of achieving absolute reductions in freight emissions overall. Another of the C's in my framework is cost evaluation. Again, there's a good news story here in that many of the things that you do to cut carbon emissions from logistics will also save money. So that rather complex diagram on the left comes from a report done by some of my colleagues for a government committee here in the UK, which looked at all the things that you can do to decarbonize road freight transport, trucking. And it's what we call a MAC analysis, a marginal abatement cost analysis, where you look at the costs of cutting carbon emissions. And the interesting thing here is that there's a red line in that diagram. All the initiatives on the right-hand side of that red line will actually save you money in addition to cutting carbon. In other words, these are self-financing measures. Remarkably few of them actually have a net cost associated with them. So therefore, I mean, many of these things are what we would call low-hanging fruit. The things that can be justified on purely commercial grounds and not simply for environmental reasons. And however, I have to qualify that. This is a diagram I got from one of my long-term academic colleagues, a guy called Laurie Tavassi in the Netherlands. I mentioned the term low-hanging fruit. I think many people feel we are currently in the low-hanging fruit phase of freight transport decarbonisation, when we can save money in addition to cutting carbon. But unfortunately, harvesting all that low-hanging fruit isn't going to get us to our target. If you imagine our target is the red dot on that diagram, that we're going to eventually have to take other measures, which will be more expensive. So there'll be a rebound phase when what we call the carbon mitigation cost will rise. And maybe ultimately to get to net zero, we'll have to enter that austerity phase when companies will have to sacrifice return on investment and profitability to get there. But that's some distance in the future. You know, to get companies started in this process, you know, they can be sliding down that low-hanging fruit curve. Just to give people a sense of how hard it's going to be to decarbonize road freight transport or freight, what we might call surface freight transport in Europe. I mentioned earlier that the European Commission wants to achieve a 90% reduction in transport emissions by 2050. So how might we achieve that in the freight sector? Well, there's one scenario. One thing we could do is transfer 30% of our ton kilometers from road to rail, and in the meantime, hope the railways reduce their carbon intensity by 80%. We could then, in the road sector, we could improve a 25% improvement in the routing of the vehicles, 30% increase in the loading of the vehicles, 30% reduction in empty running, 50% improvement in truck energy efficiency, and a 60% drop in the carbon content of the energy. Factoring all of those things together would deliver that 90% reduction in carbon intensity. Now, anyone working in the freight sector in Europe would know just how hard all of those things would actually be. Now, that's one scenario. There are other scenarios. So in the second one, we would rely much more heavily on reducing the carbon content of the energy. Because if we did that, that would take the pressure off those other parameters. So one can play around with these scenarios, but either way, it's going to be a tough challenge. And it's an even tougher challenge because we have to do this quickly. Remember, it's the accumulation of CO2 emissions in the atmosphere which drives climate change. So the longer we delay doing these things, the more CO2 accumulates. So in the freight sector, if we were to have the emissions peak by 2025 and then drop a bit more gradually to 2050, as opposed to allowing them to peak in 2035, that delay would result in about 30% more CO2 coming from freight transport over that time period. So it illustrates how important it is, not just for us to apply all of these things, but to do it quickly to minimize those accumulated emissions. Now, I've been talking here about Europe, but to take a global perspective on this, we can rely on the modeling work that's been done by the International Transport Forum, because last year they published their projections for the reduction in the carbon intensity of freight transport around the world. And you can see how they expect the EU 27 to outpace the rest of the world. That rate of decline is relatively slow in Africa and India and so forth. In the UK, it's in Europe, a Freudian slip. In the EU 27, it's going to happen a bit more rapidly. Now, this is concerning because the same document also looked at where road freight CO2 emissions are expected to come from. And it's predominantly, as you can see, from the non-OECD countries, from the lower income countries around the world. So it's in those parts of the world where the rate of freight decarbonization is slowest are the ones that are going to experience the fastest growth rate in freight. And this is, I think, these are very deeply worrying projections. So I'd like to move on now to look at the 5 categories of things that you can do to decarbonize freight transport operations. And the first one that you may recall was to reduce the carbon content of the energy used. And we have, again, a range of options for that. So I've distinguished the different transport modes, what I call short haul road, local deliveries, many of them by vans, long haul road, long distance trucking, rail, freight, shipping, and air freight. And you can see in every case, there are a range of options available, and I'm going to talk more about those in a few moments. One thing that concerns me is that, despite the fact that we have to act quickly to decarbonize, there is still a lot of uncertainty about what the right energy pathways should be. There's increasing disagreement, particularly in the road freight sector. For example, do we do this by using batteries or hydrogen, or do we electrify the highway, or is it going to be biogas? So there's a lot of disagreement. There's also intense lobbying these days by interested parties pushing particular energies, and we don't have the luxury of delaying on this, it seems to me. The other big problem that we have is the lifespan of the assets, which in the case of locomotives in the railway network and high seas with shipping and aeroplanes, these are long life assets. And it takes a long while to replace those fleets. And this, as a result, is going to mean there'll be a relatively slow transition to low carbon technologies, particularly in those sectors. And it seems to me what I've said in this box is the key challenge that we face. It's that of coordinating the development of transport and energy infrastructures for these low carbon technologies with the manufacture of the new vehicles and vessels and aircraft, and also relating that to operators' replacement cycles, vehicle replacement cycles, which in many cases span many years. And coordinating that process, it seems to me, is going to be very hard. The other thing is that we're going to rely very heavily on the electrification of freight transport with low or zero carbon electricity. Now, currently, the carbon intensity of electricity varies enormously around the world, and also the rate at which countries are decarbonizing their electricity is highly variable. Another problem is that it's estimated that world electricity demand is going to increase by 60% by 2040 as countries develop. And there are going to be intense competing demands for the available low carbon electricity in the future. For example, it's estimated that the number of electric cars in the world will rise from about 3 million to 300 million by 2040. We're going to have to switch away from fossil fuel heating of our homes to electrified heating. So given all of these competing demands for this low carbon electricity, will there be enough to decarbonize the freight and logistics sector. And that again is debatable. So if we look at the modes, in the case of road transport, those are the options: batteries, hydrogen, electrified highways, synthetic fuel or biogas. And then to complicate things, there are various hybrid permutations of these technologies. There have been several studies published in recent years trying to evaluate these different approaches to decarbonizing trucking. One from the Eco Institute in Germany, and Pricewaterhouse's strategy and group published an interesting report recently. Hard to compare their results because they make different assumptions, use different data sets. They're optimistic that this will be achieved, but they're not very sure what is going to be the right pathway. So what are these pathways? Well, I'm a big supporter of the electrification of road freight transport. It's already well underway in the local delivery sector, particularly in France, because in France you have very low carbon electricity because you rely so heavily on nuclear power. And so La Poste in France has invested very heavily in fleets of electric vehicles, taking advantage of the dramatic reduction in the cost of batteries, but also the increasing delivery range of these vehicles, and the fact that there is an expanding recharging network. So the problem isn't so much at the local level, it's at the long distance trucking level, where there's currently a lot of disagreement as to how we should decarbonize long distance trucking. For a long time, the feeling was that a long haul truck would require a very heavy battery, which would reduce the available payload on the vehicle. It would also take a while to recharge. But that has changed. There have been quite dramatic advances in truck battery technology, reducing the weight of the batteries and also increasing the speed with which they can be recharged, so that many people are now reevaluating the use of batteries, particularly in smaller countries like Europe, where the vehicles don't have to travel as far as they would, for example, in the United States. The other thing is hydrogen, using hydrogen as the carrier of low carbon electricity into the vehicles. Again, a lot of disagreement. Some people argue, and I tend to agree with them, that one wastes a huge amount of energy in electrolyzing water to make the hydrogen and then converting that hydrogen back into motion, into electricity, using a fuel cell. As much as 70% of electricity gets wasted in that process. And as I said earlier, we're probably going to be short of low carbon electricity. It's going to be a precious commodity. So we don't necessarily want to waste it. Other people say, however, that despite those high energy losses, that hydrogen still represents a very viable decarbonization option. The other point worth making is that almost all the hydrogen currently available is essentially a fossil fuel. It's made from natural gas. And it's hard to say how long it will take to get what we call green hydrogen, which is made from the electrolysis of water. And then, of course, there's the other option I mentioned briefly, which is to electrify highways. Many people, until recently, thought this was science fiction, where you put cables over the roads and you have what we call trolley trucks getting direct transmission. It's now being extensively trialed in Sweden, in Germany, and also in the United States and California. A lot of research has been done on this in Germany, where it's estimated that about 60% of heavy truck CO2 emissions come from only 2% of the road network, mainly the busy Autobahn. And so if you electrify those, you could do a lot to decarbonize long distance trucking. And also they found that almost 90% of truck trips, when they leave the Autobahn network, travel a distance of less than 50 kilometers to get to factories and warehouses. So they could therefore, in addition to have the trolley capability, they could have smaller and lighter batteries, which would allow them then to access those premises. So there's a lot of enthusiasm in Germany to electrify as much as 4,000 to 8,000 kilometers of Autobahn. They reckon that would cost between 2.5 and 3 million euros per kilometer. And this is considered a fairly cost-effective way of doing it. That's Europe. Looking at this globally, there's a problem, because how long is it going to take us to get these low carbon, what we call powertrain technologies and trucking into the less developed countries? you know, this is going to involve a lot of investment in battery charging networks and refueling and electrifying the grid and so forth. And all of these things will take a long time. Another thing that we must recognize is that a lot of the vehicles, the trucks used in the developing world, are imported from Europe and from North America. And one of the worries is that as Europe, for example, moves to battery-powered or hydrogen-powered trucks, that Europe will want to offload its current generation of internal combustion engine vehicles into the third world. And that will then drive down the cost of these vehicles. The other thing is that the new generation of battery or hydrogen powered vehicles will have a much longer lifespan, and therefore it will take longer for second-hand vehicles of that type to be exported to the developing world. So that the diffusion of these low carbon truck technologies into the rest of the world therefore may be relatively slow. And one other issue is it's reckoned there'll be a scarcity of the materials we need for the batteries, particularly cobalt, and also fuel cells. I think they have platinum in them. And therefore, many governments in Western countries will not want those materials to be included in the imported vehicle. So therefore, one can be a bit pessimistic about the prospects of this decarbonization of trucking happening at a global level anytime soon. Moving on to my second set of initiatives. This is improving energy efficiency. Taking a long-term view, we can rely on technology for this purpose. We can redesign the vehicles, we can platoon the trucks, we can automate the trucks to reduce fuel consumption. We have seen the development of fuel economy standards, forcing manufacturers of trucks and shipbuilders to produce, requiring them legally to produce vessels and vehicles which are more energy efficient. In the short term, there are things we can do. We can train drivers to drive more fuel efficiently. That's been shown to be one of the most cost-effective ways of decarbonizing trucking. We can change business practice. I published a paper in 2016 suggesting we should simply slow down freight movement. We should decelerate to reduce energy consumption. That's already been happening in the shipping sector with what we call slow steaming. And again, some companies like Geodis, for example, in France, are reducing the maximum speed of the trucks to save fuel. So a lot of things we can do under this heading. My third category of initiatives is load the vehicles better, because a lot of vehicles are running empty or only partly loaded. As an academic researcher, there's a problem here, I find, because there's a lack of good data on just how well we load freight vehicles. I published a report 10 years ago pleading for improved European freight transport statistics on this, but regrettably not much has happened in the meantime. But we do know that in Europe, about 20% of truck kilometers are run empty. In Latin America, it's between 30 and 50%. It's not just the empty ones. The other ones, many of them are underloaded. In the developing world, many of them are overloaded, which can be just as bad for fuel efficiency and carbon intensity. So what do we do about it? Well, one thing we could do is increase the maximum size and weight of trucks. Again, this is something that I'm really quite positive about because it's been shown to be quite an effective way of decarbonizing long-haul trucking. We can promote what we call supply chain collaboration, where companies work together to share their vehicles. This is a case study in the Benelux countries involving Nestle and PepsiCo, where originally the two companies delivered using separate vehicles. And the carbon intensity, as you can see, was 43.8 kilograms of CO2 per ton of product delivered. And then once they shared vehicles using a logistics provider, and adjusted their schedules to maximize collaboration, they were able to cut that carbon intensity by more than 50%. So we need more collaboration. And this next topic would probably take me at least an hour to explain in detail. It's something called the physical internet, which is a very fashionable logistics concept in Europe at the moment, which is basically applying the principles of the digital internet to the physical world, creating open access systems, to make better use of vehicle capacity. And the feeling is that if that is ever materialized, it will drive down CO2 emissions, but it's a longer term development. And that takes me into the area of ICT, of information and communication developments, of which there are many. And the feeling is that all of these will help us to decarbonize freight transport. So we're talking about the use of online platforms for the purchase and load matching of freight. It's reckoned the blockchain will make a contribution, the Internet of Things. There are major advances underway in the optimization of vehicle routing using big data and machine learning and artificial intelligence. No question, all of these things will help us to decarbonize freight. The problem is actually trying to quantify by how much, because nobody has yet done that analysis. And then moving on to my fourth category initiative, which is switching freight to lower carbon transport modes. You can understand why this is desirable if you look at the differing carbon intensity of the various freight transport modes. Virtually no CO2 emitted per ton of product. In the case of a bulk carrier, we're talking about maybe 4 or 5 grams of CO2 per ton kilometer, right through to over 2,000 grams of CO2 per ton kilometer for short haul aircraft. So it's understandable people want to shift freight to these lower carbon transport modes. If one looks at this over the years, governments have seen modal shift as the primary way of decarbonizing freight. If one looks at the nationally determined contribution statements made by governments around the world to the Paris Agreement, this has been analyzed by a friend of mine called Sudhir Gota. What he found in their NDC documents, they reckoned 48%, almost 50% of the initiatives they identified for decarbonizing freight relate to modal shift. So we can understand why this has been a very important political priority. The problem is, however, it's proved very difficult to achieve. This graph shows the modal split, the division of freight between transport modes in Europe since 2012. And you can see what has happened is the road network has actually increased its share, while rail and water has reduced. In fact, very few countries in the world have managed to reverse the long-term decline in the rail freight share of the market. And it's even harder now for the railways to increase its market share because one of the core traffics of the railways is fossil fuel. It's coal and oil. I think in 2013, 40% of all the freight carried by railways in the world was coal. And it's going to be very difficult for the railways to replace all that fossil fuel traffic with other commodities. Another thing worth noting is that the carbon intensity of road freight transport is actually currently falling faster than that of rail freight. However, to end on a more optimistic note, governments have got initiatives in place to try to attract more freight back onto the railways. Here in Europe, for example, where we have 9 intermodal corridors in which there's a lot of encouragement to companies to shift their freight onto rail. And there's a new concept called synchromodality, which, as the name suggests, is where you synchronize the interconnections between different transport modes to make it easier for companies to switch modes at different points in their supply chain. So I don't want to be too negative, but I think we're going to be realistic about what the prospects are for freight modal split. And then finally, we can try just to reduce the amount of freight that we move. Now, some of this takes us beyond the realms of logistics into sustainable consumption, into wider developments in technology. So there's a lot of talk these days about the share economy, about in the future people sharing more goods rather than possessing them themselves. A lot of discussion about the circular economy, to maximize recycling, remanufacture of goods, becoming less reliant on new resources. There are ways in which we can redesign products to use less material. We've seen this very much in the electronics sector, where we miniaturize products and we lightweight them. And of course, we can go beyond that to digitizing the products, where we can essentially convert physical consignments into electrons. Now, all of those things together reduce the amount of stuff that we have to move. And I think many of these trends are going in the right direction. There's also 3D printing, because if 3D printing were to become a dominant manufacturing technology, that would help to streamline supply chains. It would reduce links in the supply chains. It would localize production. It would reduce the amount of waste in the production process. I published a paper a couple of years ago where I suggested that 3D printing might be what we call a decarbonizing silver bullet. When I published it, there wasn't a question mark. I had a question mark, but the publisher of the article removed the question mark. So I wasn't arguing this, I was merely speculating that this would be possible. But again, I think one could be hopeful that 3D printing will contribute. And then I think this is my final slide. There are some trends that will push in the opposite direction, because of climate change, there will be other forms of freight traffic that will be generated. And currently, this climate-related growth in freight movement isn't factored into the freight forecasting models. So there's a very good chance that we are going to overshoot our carbon reduction targets. And we're not going to stay within the carbon limits for a 1.5 degree temperature increase, for example, in which case we will have to invest a lot of time and effort in what we call negative emissions, drawing down many of the greenhouse gases already in the atmosphere. Now, the hope is, of course, that much of that will be done by what we call rewilding, by using the natural world, by planting trees, for example, to do that. But it may be we will have to use mechanical means, using what we call direct air capture, using scrubbers to remove the CO2, or a process called BECCS as well. Now, we have to go beyond that to engage in what we call geoengineering to save ourselves from runaway climate change. Now, all of these things would have to be done at a planetary scale, and regrettably would tend to generate a lot of freight movement. We're also going to have to adapt our built environment to climate change. That process is already well underway, because even if we stopped all our emissions today, there would be lag effects. We're going to be suffering extreme weather events for many years to come, and so we have to protect ourselves. That again is generating a lot of freight movement. Resettling population, I think 200 million people in the world live within 5 meters of sea level. Again, we're going to have to rehouse those people, and the construction involved will generate freight movement. On the other hand, climate-induced disruption of supply chains, it seems to me, will discourage companies from moving goods over long distances. As we've seen in the pandemic, a lot of companies are now prioritizing resilience, trying to minimize the exposure of their supply chains to extreme weather or other disasters. So if we look at the effects of these 3 sets of trends, the top 2, it seems to me, will generate a lot of extra freight movement. The last one will probably dampen demand for freight transport. So, but I think what we need to do is more research on these areas. And so that's my presentation. I hope you found that of interest, and I'll be very happy to answer any questions. I'll just flag up a few things. Just yesterday, we published a new report looking at decarbonization efforts in logistics across Europe. You can see the link there to that report. I'm also the author and co-author of 2 books on this subject. My book on decarbonization of logistics was published in 2018, and I've also, with others, written a book on green logistics. So there's plenty of reading material there if you'd like to pursue any of this. Those are my contact details at my university. If you have any queries, by all means, drop me an email. So I'll hand you back to Patrick at this point, and I'll be happy to answer any questions that you may have. Thank you.
Okay, thank you very much. So thank you very much, Mr. McKINNON, for your very interesting presentation. And I'm very, it's very nice to meet you, even if it's online, of course. Yeah. Well, you mentioned among your 10 C, 1 C about collaborate with others. And as I am a professor of strategic management in the ESC Clermont Business School, of course, I am interested in these topics, this specific topic. And I'd like to know what could be, according to you, the first step to make that the different stakeholders concerned by this questions of decarbonizing transport, how to make all these stakeholders could join this movement and could work together in order to implement some options that you mentioned.
Yes. That's a very good question. The report which I mentioned we published yesterday has a section on this very subject. Because so we surveyed about 92 senior executives in logistics across Europe, and they were pretty well all agreed that we need to collaborate more than we do. But we also asked them, what are the constraints on collaboration? And it was the obvious things. It was management culture. It was lack of trust. It was fear of the partner behaving opportunistically and capturing all the benefits. It was worries about infringing competition law, for example. So there are lots of good reasons for not doing it. And you know, there's been so much discussion about supply chain collaboration for decades, right? And yet still it's the exception rather than the rule. So there has to be something that gets companies over that initial barrier, right? One thing that helps is having an external organization that can act as a trustee, that's independent, acts as an honest broker. And we've begun to see the development of such organizations that can provide that service. The other thing is good examples, good case studies. So I showed the one there of Nestle and PepsiCo. In my book, I've got a whole list of other ones as well. And these are big companies. So one of the main advocates in Europe of supply chain collaboration is Procter & Gamble, right? They're very happy to work with lots of companies. Kimberly-Clark is another. So that sends out positive messages, I think, to other companies to do this as well. And of course, organizations can help. You know, so there's an organization in Europe called LUPEG, horrible name, but what it does is to raise the profile of collaboration and encourages companies to do it as well. So I think we can be positive that you know, there are going to be improvements in this area through time.
Okay, thank you very much. And of course, my research focuses on co-opetition, which is a mix between competition and cooperation. And of course, there is a concept called co-opetition capability. And I think it's interesting to perhaps study this specific idea with what you mentioned. Okay, thank you very much.
Thank you.
The next question is from Alexis Zissos, from the Sigma Technical University in Clermont Ferrand as well. Please, Alexis.
Thank you very much. Well, I'd also like the opportunity to thank you for this very interesting presentation, a very interesting topic. I have a question specifically on your last point. I think it was the fourth one. You were talking about trends in the shift, you know, from companies. And I find personally that there is a trend, especially in the marketing sector and publicity. So companies are putting forward their strategies in a marketing perspective, but wouldn't you agree that companies are still very much driven by the consumers and by the customers, and what customers and consumers do in logistics tend to favor the quickest delivery response, the shortest lead time to delivery. So what's your opinion on that?
Alex, that's another excellent question. It would take me about 2 hours to answer it properly. Again, going back to the survey we published yesterday, we asked the executives what the main external pressures were on them to improve the environmental performance of their logistics. And top of the list was customers. So they feel that a lot of their customers these days are putting them under pressure to become more environmental. But what you say is right. There are a lot of worrying consumer-related trends, I think particularly in online retailing, when many consumers are promised almost instant delivery for free. And people are able then to buy lots of goods and then return them, which are very wasteful logistics practices, and they carry a very high carbon penalty as well. I mean, I would like to think that through time, the message will get across to customers. And by that, I don't just mean consumers, I mean business customers as well, that we have, you know, the biggest existential crisis facing us in climate change. And that will then impact on buying behavior, and the customers and those demanding the products will force the suppliers to improve their practice. But we also have to do something, it seems to me, to control the misuse of logistics on the last mile of online deliveries to the home. And we have to guard against what we call in English greenwashing, you know, companies which say we're doing great things for the environment purely for marketing purposes, when in effect they're really not doing very much at all. So there's a lot of work to be done here, but yeah, great point.
So going on to my second question, because it was kind of linked to what you're saying right now. So basically the shift is not only focusing on the companies and their strategy, but also changing the mindset of the people. And so wouldn't you agree that on the question that was asked previously, what strategies, you know, to work on that outer layer of that diagram you were talking about, the large corporations, the ones that are going to influence the smaller companies, wouldn't that shift be driven mainly by meaningful long-term political decision making? And as you said as well, though, the help from third-party organizations. But how concretely can that shift be sort of, you know, kickstarted?
Again, a great point, and that it would take me a while to answer it properly. Just one thing you said, which I could maybe elaborate upon, is the high degree of fragmentation in the logistics sector. In Europe, for example, we've got over 500,000 small trucking businesses, many of them just running one vehicle, right? So how do you get them to reform their operations? There's another report my university is publishing in 2 weeks' time on this very subject. And you mentioned the role of the big players, because big logistics providers subcontract much of their freight transport to these small operators. And it seems to me they have a key role in enforcing good environmental practice upon them, to get them to raise their fuel efficiency, upgrade to cleaner vehicles as well. But then beyond that, and this is the other point you made, is the role of government, which is, I think, is critical in all of this, because they're setting the regulatory frameworks. Longer term, it seems to me the game changer, all of this is going to be carbon pricing, right? We monetize carbon, it appears in the balance sheets of the companies, and that is for governments to do, clearly. We have an emissions trading scheme in Europe, but it really doesn't relate very much to the logistics sector at the moment. It's only some air cargo which is included. So governments therefore can use the price mechanism, and also regulation. I mean, one other thing I didn't say much about was in Europe, we have fuel economy standards for new trucks. So that new trucks sold in 2025 will have to be 15% more carbon efficient than vehicles sold in 2019, right? And that threshold is increasing. So there are good things happening, and if my general conclusion is this is a multi-stakeholder exercise. We've got so many players. We've got the consumers, the logistics providers, the manufacturers, the government, and somehow they've got to all coordinate this to help us to drive down freight emissions.
Thank you, Alan. Thank you very much.